All right, this is Honors Algebra 2 Pre-Calculus. We're doing 4.5 in Pre-Calc, the graphs of sine and cosine functions. So in this video, we're going to walk through E1 and P1 to learn how to create the basic sine and cosine graphs. After that, you're just going to want to add them to the list of functions that you memorize, like x squared, x cubed, natural log of x, etc. Then we'll talk about transformations of sine and cosine graphs. But again, in E1 and P1, we're going to walk through how to actually make these graphs. So all right, so using the unit circle, we're going to fill out a table and then graph y equals sine x. I chose the corners of the unit circle, meaning the axes, right? 0, pi over 2, pi, 2 pi, etc., 3 pi over 2. But I also chose the pi over 6's because sine is a nice, happy, rational number at pi over 6. It's a half. So, okay, so sine of 0, right? So remember, we want the y on the unit circle, right? And if you want to picture a unit circle down here, right? Sine of 0 is 0, right? Because that's the y value. Right, sine of pi over 6 is a half, right? So it's a half. And then sine up at pi over 2, well, that's a 1. And then at 5 pi over 6, we're back to sine being a half, right? At pi, sine is a 0. At 7 pi over 6, it's that same half, but it's negative now. At 3 pi over 2, sine is a negative 1. At 11 pi over 6, sine is a negative 1/2, and then at 2 pi, we're back to 0. So let's look at what this would graph like, right? So here, x is my angle, right? X is the angle. So I get the point 0, 0 right here, right? Pi over 6 is a little tricky because here's pi over 2, right? So pi over 6 is like a third of that. So at a third, I'm around a half, and then at pi over 2, I'm up at 1, right? 5 pi over 6 is just about 2/3 of the way here, so that's half, and then I'm down at 0 again, and then again I'm down at 1/2, and then at 3 pi over 2 I'm at negative 1, which I kind of missed a little bit. You get the idea, right? And then at just a little bit after, or a little bit before 2 pi, I'm back at a half, and then at 2 pi I'm back to 0. So this is what a sine function looks like, right? And sine is what's called periodic. So this same shape that just happened here, right, that same shape, is going to happen again right here. So it's going to be the same shape. And I'm not going to pretend to be good at graphing, and that's going to happen an infinite number of times. It's a sine wave, actually, right? It looks like a wave. In fact, we'll talk about how sines and cosines can be used to model wave behavior and behavior of things that like vibrate or oscillate because of this pattern. So this is a sine function. This is what y equals the sine of x looks like when you graph it. You'll notice that the top value is at 1. The bottom value is at negative 1, despite my inability to graph, right? And then, so it's called periodic, right? And the period of sine, which we'll spend some time with in a little bit, but the period of sine, the time that it takes to complete one full wave, right? The period is how long it takes to complete one full wave, and that period is 2 pi. All right. So you're going to go ahead and try the same thing in P1, but you're going to do it with cosine. Spoiler alert, it goes very similarly, like it's the same basic idea. So you're going to go ahead and try this with cosine. Notice that I use the pi over 3's instead of the pi over 6's because for cosine, the pi over 3's are the nice happy numbers, right? So again, if you picture the unit circle, right, if we start here at 1, 0, right, the cosine of 0 is 1, right? And then here at pi over 3, the cosine is 1/2. And at pi over 2, the cosine is 0, right, because it's the x-coordinate, so 0. Here we have the same value but negative because it's an x value, so the x value is negative 1/2. And then negative 1 is the x value. Then back to another negative 1/2. And then another 0. And then a positive 1/2. And then back to being a 1. So if we go ahead and plot these points, right, the plot is 0, 1, right? And then at pi over 3, which is sort of here-ish, right, it's close to pi over 2, but it's not quite there yet, I get a half. And then at pi over 2, I get a 0, right? And then at 2 pi over 3, I get a 1/2. And then at pi, I get a negative 1. And I get another half. And then at 3 pi over 2, I'm back to 0 again. And then another half. And then at 2 pi, I'm back to 1. So it looks kind of like this. Again, I don't pretend to be good at graphing things. You get the idea. So if we repeat this wave, because it's also going to repeat the same way the last one did, what you're going to see is it's actually the same basic wave. It's just shifted over. It starts in a different spot, but it's shifted over. So if I were to switch back and forth between the two graphs, you would see, and we'll do that in a sec, that they're basically the same graph. They just start in a different spot. So again, notice that this tops out at 1, it bottoms out at -1. Notice that the 1 period, right, the time it takes to complete a full wave, right, full wave, and because this is the exact same wave, the period is a 2 pi. So period is 2 pi, right? And if I flip back and forth, you'll see that they're the same graph. So there's sine, there's cosine, there's sine, there's cosine, right? They flip back and forth, they're the same graph, but just a little bit different where they start. So here's the difference. Cosine starts up. What I mean by starts up is that this is our y-axis, right? At the y-axis, cosine starts up, whereas sine starts in the middle and then goes to the top. So what I want you to notice about this graph is basically you can graph this. There's only 3 values that really matter, and they're the 3 values that matter at the corner, right? So here are the corners. 0 is a corner on the unit circle, so is pi over 2, so is pi, so is 3 pi over 2, so is 2 pi. Look at how at the corners, my graph, so cosine starts at 1, at the next corner it's 0, at the next corner it's -1, at the next corner it's 0, and then at the last corner it's 1 again, and I can connect those dots. The same thing's true with sine. Sine of 0 is 0, but at the next corner on the unit circle, at pi over 2, sine is a 1. At pi, sine is a 0. At 3 pi over 2, sine is a -1, and then it loops back to a 0. And you could sketch that graph with only those values. So you want to memorize that cosine starts up, because from the top, it's going to have to go to the middle and then all the way down and then back to the middle. It's the same pattern forever. Sine starts in the middle and then goes up. And it's going to matter when we're graphing things. So it is worth noting that if you put a negative in front of the cosine, right, it starts down. So essentially, if you put a negative, remember it flips across the x-axis. So if you put a negative, regular cosine started up, and this is going to start down. Regular sine started in the middle and went up, but this is going to do the reverse. It's going to start in the middle and go down. So it's just worth noting. All right. When we talk about graphs that are worth memorizing, you should, at this point, already hopefully know these, right? These are new. And in 4.6, we're also going to add that you should know the other 4 trig functions. That's not how you spell 4 that I want to spell. 4 trig functions. Okay. All right. So it's worth having it doesn't have to be a perfect sketch, but you should have a rough idea what these graphs look like. Okay. All right. So let's talk about transformations on sine and cosine graphs. So whether I use a sine or a cosine or a negative sine or a negative cosine, that's like the basic graph I'm going to start with. But these 4 letters, A, B, C, and D, they're going to inform how I can graph the sine or cosine function based on those numbers without actually spending a lot of time like plotting points and figuring other stuff out. So this A in front, the absolute value of A is called the amplitude. That's how high the waves come up and down off sea level. So let me show you what I mean by sea level. We just saw a sine graph and a cosine graph, and I told you there were really only 3 values that were important, right? There was the bottom, the middle, and the top. So sea level, right? So sea level, this thing that I put in green right here, sea level, right? This is sea level. And then what happens is the waves come up and down off sea level. So the waves rise and then they fall, and then they rise and then they fall. How high the wave comes off of sea level is called the amplitude A. But it's the absolute value of A because it's a positive number. It's a scalar. It's how far, and there should be another parenthesis here, but we'll survive. It's how far the wave comes up and down from sea level. Frequency, B, refers to how fast the wave moves. So here's what a low frequency looks like. Low frequency, long period, right? So that's low frequency. And here's what a high frequency wave looks like. High frequency, right? And that actually does refer to the frequencies and the waves that you hear and the light, like visually the spectrums that you can see. When we talk about the frequency that you can see, when we talk about a frequency that you can hear, that a dog can hear a whistle that you can't hear, that's about frequency, right? A low frequency wave sounds like if you hear a foghorn coming from a ship, you're talking low frequency wave. But if you hear like a really high-pitched squeak, right? If you hear like a dog whistle that's really hard to hear, but you can kind of hear it, or those sounds that old people like me can't hear, but you teenagers can hear, so you could set your phone ringer to be that noise, those are high-frequency noises, right? Phase shift, which we're going to do later, and I'm annoyed that I keep forgetting parentheses. Phase shift, which we're going to do later, is C over B, and that moves the graph, the start value, that moves the y-axis, because if you notice up here, I said I said starts up. Well, its start is at the y-axis. If there's a phase shift, it moves the start value left or right, and we'll talk about that. Sea level is going to be this plus d. It's going to be how high the resting wave sits. Because if you think about it, we don't live anywhere near a lot of water, but if you think about the way tides work, when tides come in, they raise the sea level, right? And then off of that raised water, waves still go up and down. And you see that in like the Schuylkill when it rains, right? If there's a lot of rain, the physical level of the water rises, but then there's still little waves in the water, right? The waves go up and down from whatever the standing level of the water is, but the level of the water could be different if there's a lot of rain. And then the last thing is that the period is 2 pi divided by b, which kind of makes sense because see how this would be a really long period because b is a really small number, right? But if b is a really high number, then the period is really short. You repeat a wave really fast because it's a really high number. So, all right, let's go ahead and walk through how we're going to graph this. So I have a pretty good system for how I graph these. You certainly don't have to do what I do, but it works, and it's worked for a long time. So here's what I do. I figure out which graph I'm graphing. Is it a sine, cosine, negative sine, or negative cosine? I figure out what sea level is and draw a dotted line. I figure out what the amplitude is, and I draw the top and bottom lines. So let's go ahead and start walking through some of this. So I have y equals 4 sine of 2x minus 1. Okay, so let's walk through some of these values. First thing, the amplitude is 4, right? That's the amplitude. That's how high this wave is going to come up off sea level, right? And sea level, so sea level, which is not in any way a math term, is negative 1. Okay, so let's go ahead and draw a graph that's going to accommodate that. So I need to go start at negative 1 as my middle of the road, right? So I'm just going to put SL for sea level, right? I've got negative 1. And then I need to go up and down 4 units from that. So 1, 2, 3, 4. I need to be able to go down 4 units. That's the bottom, right? And my wave has to be able to go up 4. So 1, 2, 3, 4, right? And then that's the top. Okay, so that's the top. That's what I need. Okay, so I know that right away I look at this and I say, hey, it's a positive sign. So I'm graphing a positive sign. I drew a dotted line at sea level. I drew top and bottom of the waves, right? Okay, so I need to find the period. The period of this thing, right, the period is going to be 2 pi, which is the normal period of sine without any adjustments, divided by b, which is 2. So the period is going to be pi. Then what I'm going to do is I'm going to draw one full period on either side of 0. So I'm going to say, cool, this is pi, and this is negative pi. One period on either side of 0, and I'm going to cut the period in fourths. The reason I cut it in fourths is because, remember, we're using these values on the unit circle, right? So if this is one full period, right, so a loop is 1 period, right? Wouldn't this be 1 quarter, 2nd quarter, 3rd quarter, and then back to the beginning? So I want to cut this in 4s. So cut it in half, cut the halves in half. Honestly, I don't care if you label your axes particularly. You can if you want, but I don't really care. So I cut it in fourths, and then I'm going to follow what I know a sine does. A sine starts in the middle, meaning at sea level, and at the first hash mark, it's going to go to the top. At the next hash mark, it should go back to sea level. At the next hash mark, it goes down to the bottom. And at the last hash mark, it goes up. And sure enough, there's my sine wave. And sure, it's not quite as curvy as it should be, and that's fine. And I can keep going, right? So up, middle, the next hash mark should be down, back to the middle, back to the top, back to the middle. And make sure that you're going to sea level for that middle, not the axis, because the axis isn't always sea level. And that's my graph. All right, so we're going to go ahead and try P2. You can certainly pause me if you want. So I'm going to recopy this a little bit bigger because, you know, I'm blind as a bat. So y equals 2 cosine of 4x quantity plus a 3, right? So first thing I should recognize is that this is a positive cosine graph. Right? So the first thing, right, so it's a positive cosine, right? It's worth noting that that means that it starts up, for lack of a better way to say it. The second thing is that my amplitude is the absolute value of 2, which is 2, right? That's my amplitude, so that's how high I'm going to come off of sea level. And my sea level is 3, right? So positive 3 is my sea level. The water level has risen up to 3. So let's go ahead and start with that, and then we'll find the period in a sec. So I know that my sea level's at 3, so ignore that. 1, 2, 3. That's going to be sea level. 1, 2. So I need to be able to come 2 units off of sea level. So that's 2 units above sea level. That's the top. My sea level is at 3, and then 2 units below sea level would be at 1. Okay, so those are my 3 lines. The next thing I need to do is I need to find the period. So remember, the period is 2 pi over b, which in this case is going to be a pi over 2. Since I don't really care if you scale your axes, you can basically just put a period on either side. If you want to figure out what half of that is, right, that's a pi over 4, and then half the halves, those are pi over 8s if you count. That's fine, but I'm really okay with you just cutting the period in 4. When we get to phase shifts, you're going to have to pay a little more attention to the scale, but honestly, this is just fine. So I do all that, and then I say, cool, it's a positive cosine. So that's when I start using this information that cosine starts up. So I say cosine starts up. There's nowhere to go but down if it starts at the top. So at the first hash mark, it's going to go down to the middle, and then it's going to go all the way down to the bottom at the next hash mark. At the third hash mark, it's going to go back to the middle, and then after 4, it should end where it started, because that's the idea of one full period, right? So that's one full period of the graph, and it ends where it starts, right? And then I do the same thing on the other side, down to the middle, all the way down, back to the middle, back all the way up. And notice that after those 4 turns, I should have rotated back to the starting position, okay? And there's my graph. All right, so the first thing I do here is I spot that this is a negative cosine, right? So y equals negative 5 cosine of x over 2, or you can treat it as a 1/2 x minus a 3. Okay, so number 1, it's a negative cosine, right? Negative cosine is going to start down. It's going to, so instead of starting up, it's going to start down, right? Second thing I notice is that the absolute value of negative 5 equals 5 is my amplitude, right? Third thing I notice is that negative 3 is my sea level. So when I graph this, I need to be able to start down at negative 3 and then go down as far as 5 units below that, which is a negative 8, and up as far as 5 units above negative 3. So I'm going to need a lot of space down below the x-axis, right? And then the last thing I probably need to find is the period, right? B in this case is a 1/2, right? X over 2 is the same as a 1/2 x. So my period is going to be 2 pi over 1/2, which is a 4 pi. All right, so knowing all that information, let's go ahead and plot some stuff on this curve. All right, I know that I need to have sea level at negative 3, so 1, 2, 3. That's my sea level, right? And that's fine, but the hard part about it is that I need to be able to go down another 5 units. So 1, 2, 3, 4, 5. That's the bottom of the wave. And up 5. 1, 2, 3, 4, 5. Up 5, okay? And then I need to take the x-axis and I need to put 1 full period, which is 4 pi on either side. So 4 pi on either side, and cut the half in half, or cut it in half and cut the halves in half. Cut it in half and cut the halves in half. Now each one of those hash marks is going to be pi in this case because it was a 4 pi, so you can count pi, 2 pi, 3 pi, 4 pi. But we don't really care. You'll care when there are phase shifts, and we'll do more work on that when we have a phase shift, but right now we don't, so why do extra work? All right, so a negative cosine starts down, so at start, which is the y-axis, it's going to start at the bottom. At the first hash mark, it has to go to the middle, and the next hash mark, it goes all the way up. Back to the middle, all the way down. And notice I started and ended at the same spot. My dotted lines didn't turn out to be very horizontal because I'm bad at graphing, but you get the gist. Same thing over here. At the first hash mark, it has to go to the middle, all the way up, back to the middle, and then all the way down. And you can see that I got 2 full periods. And if you kind of miss a little like I did, that's fine. Like, go over it again with the pen, put a note if you're worried about it. It should be curvy. It shouldn't be straight lines. So if it looks like it's not curvy, you can try to curve it out a little bit. And, you know, worst case scenario, you leave me a note that says, Hogan, I hate drawing. It's fine. All right. So you go ahead and try this one. Again, identify what the graph is, right? Which graph are you using? A sine, cosine, negative cosine, and then find those values and sketch the graph, right? Feel free to pause me if you want. So number 1, I notice that this is a negative sine, right? So negative sine is going to start middle, go down, right? Because a regular sine starts in the middle and goes up, right? Second thing I notice is that the absolute value of negative 2, which is 2, is my amplitude. I then notice my sea level is a +6, so +6 as the sea level. That means the sea, that says seal level because my brain is tired. +6 as the sea level, right, which means up high, right? And then the period is going to be 2 pi divided by, and this x over 3 is the same as a 1/3 x, so it's going to be a period of 6 pi. So let's go ahead and put that stuff on, here, right? So sea level is a 6, so 1, 2, 3, 4, 5, 6. That's my sea level. Right? And then I need to go up and down 2 from that. So down 2 is easy enough. I've already got those points, right? And up 2 will be about here. And again, I'm not really grading if you're able to draw a symmetric graph. It's cool. I'm fine with it. The period's 6 pi, so I'm going to put a 6 pi on either side of the y-axis. 6 pi and negative 6 pi, cut it in half, cut the halves in half, cut it in half, cut the halves in half. All right? And then we'll go ahead and plot our points, right? So I know that this starts in the middle, right? Sine starts in the middle, and it would normally go up, but this is a negative sign, so it starts in the middle, and at the first hash mark goes down, back to the middle, all the way up, back to the middle, right? And again, notice I started and ended in the middle because that's what should happen if I graph one full period. If I do the same thing on the other side, up, back to the middle, down to the bottom, back to the middle. And then there's my same wave again, right? Same wave again.